Hello everybody. In this video I'm going to explain you about subchapter of chapter 15, which is multiple integrals in the calculus 3, and the subchapter that I'm going to explain you is double integrals in polar form. So why double integrals in polar form? There are two reasons why we use double integrals in polar form. Because double integrals in polar form, it makes integrals easier. And another reason is we can use double integrals in polar form to evaluate the boundary, the area that bounded by the polar equations. And here is I'm going to recall you some formula about the polar equation, that x is always equal to all cosine theta and y is always equal to all sine theta, and x squared plus y squared is always equal to all squared, that all is the radius of a circle, and tangent theta is equal to y over x. And we can switch the function in the term of x and y by substitute x by all cosine theta and y by all sine theta. And here the formulas of double integrals in polar form. We can switch the double integrals in polar form from the normal double integrals of functions of x and y by substitute x by all cosine theta and y by all sine theta and dA by all d theta. And so why dA is equal to all d theta? Here I want you to see is this is the general formulas of the areas of a sector. But suppose we want to find this area, what we gonna do? If we just minus the entire area with the radius of b by the area with the radius of a, right? So the entire areas of radius of b is equal to 1/2 b squared theta is the x, and the small area with the radius of a is equal 1/2 a squared times theta as well, because it's the same x, right? So we just factor 1/2 theta, then we get b squared minus a squared, and b squared minus a squared is equal to b plus a multiplied by b minus a. So what I want you to know here, what is b plus a over 2? When you take b plus a over 2, you will get the arc that radius is between a to b, right? And b minus a is the change of the radius from here to here, which is delta a and multiplied by delta theta. So suppose that when we chop this area into smaller, then what it's going to be? When we chop it into smaller area, that delta and delta theta, it will going to be closer and closer to 0, right? So when it's going to be closer and closer to 0, that all k will going to be closer and closer to all, right? So that's why dA is equal to all d theta. So by just substitute dA here, then we will get the formulas of the double integrals in the polar form. And in order to make you guys more understand about this concept, I provide you some example. So here is the example 1. Consider the region which is bounded by the y-axis and the circle of the radius of 2 and the line y equal to square root of 2. In order to find the areas of the region, we first have to draw the region, the graph that bounded by all of these equations. And here is the graph that I draw, that is the circle of radius of 2, and this line is the line of y is equal to x, and here is the horizontal line that that the line of y is equal to square root 2, and here is the region that bounded by all of this equation, and that region is the region that we're going to find its area. So as we can see here, when we draw a line from the origin to the surface of the circle of radius of 2, we can see that that line is crossed the line of y is equal to square root of 2 first. Then it's called the surface of a circle of the radius of 2. That's why our orb is bounded between square root of 2 to 2. And our theta is bound from pi over 4 to here, which is pi over 2. Then substitute it into our polar equation and we get double integrals of polar equation of this area. Is double integral of all d or d theta defined that all from square root of 2 to 2 and theta from pi over 4 to pi over 2. Then evaluate this integral, we get all integral of all d is equal to 1/2 all square defined from square root of 2 to 2. Then substitute the number in and we get 4 minus 2 over 2 times d theta. And 4 minus 2 over 2 is constant, then we get integral from pi over 4 to pi over 2 d theta. Then integral of d theta is equal to theta, then we define from pi over 4 to pi over 2. Substitute the number in and we get pi over 2 minus pi over 4 and it's equal to pi over 4. And here is the answer of our example 1. Now going to example 2, which is find the double integral over regions of the functions of x and y over an areas of dA. That region is bounded by x squared plus y squared is equal to 4 and x equal to 5 and x is equal to 0. I said before, in order to find double integrals over a region, we first have to draw the region, and this is the region that I have drawn, and this is the circle of radius of 2, and here is the circle, is the length of y equal to x, and the vertical line y is the line of x equal to 0. And here is the area that bounded, and the area that we will find, that we're going to find, that we and that area is the area that we will use the double integral to find it. So as we can see here, our f of x and y is equal to x and y. So as you can see here, our functions of f of x and y is equal to x multiplied by y, and substitute x by all cosine theta and y by all sine theta, then we will get all cosine theta multiplied by all sine theta, and f of all cosine theta, then f of all cosine theta and all sine theta is equal to all square cosine theta sine theta. So we can do it as before by draw a line from the origin to the surface of a circle, and we can see that our orb is bounded between the region to the surface of a circle which is radius 2. So that means our orb is bounded from 0 to 2, and here is our theta bounded from here to here, which is from pi over 4 to pi over 2. So then our double integrals of x and y dA going to be double integral f of x and y is all square sine theta cosine theta, and dA is equal to all d or d theta, and our all is bounded from 0 to 2, and our theta is bounded from pi over 4 to pi over 2. Then just evaluate the integral and you will solve the problem. So now we're going to evaluate this integral, which is integral of all square dr is going to be r cubed over 3 by simplifying this one, as you can see, all square sine theta cosine theta times all the d theta, then all square times all is going to be all cube, right? Then just evaluate this integral of all cube dr is going to be all to the fourth over 4, defined from 0 to 2. Just simplify this one, we get 16 minus 0 over 4. Then 16 minus 0 over 4 is going to be 4 cosine theta sine theta d theta. And this one is going to be 2 sine 2 theta, because 2 sine theta cosine theta is equal to sine 2 theta. Then just evaluate this integral, and our integral is and we get negative cosine of 2 theta defined from pi over 4 to pi over 2. And this one is equal to negative of cosine of pi minus cosine of pi over 2. And cosine of pi minus cosine of pi over 2 is equal to negative 1 minus 0. So then we get negative 1 multiplied by negative 1, and our answer is 1. And here is the answer of our example 2. And I hope you guys. And this is all about the double integrals in polar form. I hope you guys better understand about this chapter, and thank you for your time to watch this video. And this is all about double integrals in polar forms. I hope you guys better understand about this point, and thank you for your time.